Okay, so the last little bit we're going to look at is locating a logarithm between two integers. Now, to do so, if you don't have a calculator like the one I've got on my screen, which, you can put a log button straight in, which is really bloody handy, sometimes you'll be given logs where you can't actually do that. Now, on your calculator, the log button you have will look like this, or should look like this on most calculators. Okay, this is just shorthand on your calculator for a log of base 10. Okay, so log of base 10. So if I was to put in 100 in this, so I'm saying, 10 to the power of what is equal to 100, you should know that that's 2. And if I hit equals, there we go, we get the 2. So what we need to do in some cases is we need to actually just essentially guess and estimate what we think the answer is going to be. So let's have a look at some examples of what I mean. We've got part A and part B here, which is evaluate the following. Now I'm going to do part B first because it's already in log 10 form. Okay, so part B, which is log of 10 of 1, 2, 3, 4, 5, 6, 7 zeros. Okay, and so this, I'm just going to put it straight in my calculator. 1, 2, 3, 4, 5, 6, 7, hit equals, there we go, it's 7, because 10 to the power of 7 gives us 10 million. Okay, now for part A, you'll notice we have the log of 5. So what I'm going to do is I'm going to rearrange this into our index form, which is, 5 to the power of something is equal to 78,125. Now we know that 8,125 is a very big number, and there might not possibly be a power of 5 that gives us that solution. So what we're going to do is we're going to just put in some numbers until we can get what we want. So I'm going to start off by putting in 5 to the power of 6, okay? So we get 5 to the power of 6 is equal to 15625. Okay, well that's too small. Let's try a little bit bigger. We'll go 5 to the power of 8. 5 to the power of 8 is equal to 390625. And now that's too big. But what we notice is that 78,125 must be somewhere between 5 to the power of 6 and 5 to the power of 8. So our first assumption would be, well, let's check 5 to the power of 7. Oh, beautiful, there it is. So 5 to the power of 7 is equal to 78125. So when we evaluate log 5 of 78125, our answer is equal to 7. And that's the final answer. So when we evaluate that one, we get 7. Now, let's say it wasn't 78125 and it was like 79,000. What we'd then have to do is we'd say, okay, well, this is too small, so we'll have to try something a bit bigger. So let's put 0.1 in. Now, 0.1 is a bit too big, so half of 0.1 is 0.05. Put this in. Okay, that's too small, so 0.08. Still too small, 0.09. And you can see what I get. This is too big, so 0.85. Okay, too small, so 0.87. Okay, and we can keep putting in numbers until we get really, really close. Okay, I'm not going to continue doing this, even though I'm actually enjoying it quite a bit. Still too small, 9.5. Oh, just a bit too big, 9.4. Still too big, 9.2. Too big, 9.1. But you get the picture, okay, so still too big. Oh, wait, 4 was too big anyway. Anyway, that's weird. It keeps giving me similar numbers. Anyhow, the idea is that we can keep trying until we get closer and closer and closer to what we get. Again, it's just going to be an estimation, so that would be more than enough for that one. But that's pretty much how we do those ones. So a good example of this is, say, consider you have a cheese with mold that doubles in amount every day. So suppose someone asks how many days it takes for the amount of mold to increase by a factor of 10. So if it's doubling every day, when's the first point that it starts multiplying by 10 or more? Okay, so after the first day, it's doubled. It's gone from 1 to 2, so it's multiplied by 2. Okay, from the second to third, from first to second, it goes from 1 to 2. Second to third, it goes from 2 to 4, so again, it multiplies by 2. But the third, fourth, it multiplies by 4. Okay, get from 4 to 8. Well, it's still multiplying by 2, but you see what I mean. The factor is getting higher and higher and higher. So when is that number going to jump into the tens? Okay, well, it has to be somewhere between the 8th jump and the 16th jump. Okay, because if we keep going up by 2s, 2, 4, 8, 16. Okay, so the 10th jump is somewhere between 8 and 16, so somewhere between the 3rd and the 4th day. With that being said, that's the end of this little logarithm section. What we're going to do in our next lesson is actually look at some log laws, which are very similar to and actually are pretty much derived from our exponential or indice laws.